I'm going to be looking at the rules of indices, what I like to call playing with powers. We will start off with a brief introduction and gradually build up to being able to simplify or evaluate all these kinds of problems. So let's get started. Okay, we'll start off with some small numbers. We'll go 3 times 3, which of course is going to be 9. And when we see this, 3 times 3 we can say is 3 squared. And we do this, we call it squared because it's the number of squares we would have if we went 3 times 3. Similarly, if we went 3 times 3 times 3, well 3 times 3 is 9, times 3 is 27. And we call that 3 cubed, because we would end up with 27 cubes. And I think you can see by showing something is cubed or squared, it just makes it simpler than writing all this out. For example, we did something like this. There we had 2 of them, squared. There we had 3 of them, 3. And here we've got 1, 2, 3, 4, 5. So we call that 3 to the 5th. Okay, let's see what happens if we do some divisions as well. So we'll take 3 cubed divided by 3 squared and see what happens. I think we can see that that 3 will divide into that 3 there, because that's exactly the same as saying 3 times 3 over 3 times by 3 over 3. And 3 over 3 is 1. And so we're going to be left with 3 squared divided by 3. We can divide that into it as well, and we're going to end up with 3. But this 3 doesn't have a number, does it? Well, we can give it a number. If we went back to this where we had 3 times 3, we had 2 of them squared, and 3 times 3 times 3 cubed, and here we had 5 of them, so we could call this 3 to the 1. But usually a number on its own, we don't bother to show the 1. And we're going to have some rules here which we can work out now. So let's just clear that a moment. We do 3 to the 5 divided by 3 cubed. See what happens. These cancel. We're left with 2 of them, 3 squared. And the rule is these subtract. 3 squared. So when we're dividing, we subtract, which of course brings us to what would happen if we multiplied. We do 3 cubed times 3 to the 4th. There's our 3 cubed times by 3 to the 4th, 4 of them. Well, we can just imagine these brackets have gone and we just count them up. 1, 2, 3, 4, 5, 6, 7. 3 to the 7, we add them together. So now we have a general rule, so let's put that down. Let's say a to the x times by a to the y equals a x plus y. And with division, a to the x divided by a to the y equals a to the x minus y. And we also found that a on its own is a to the 1. I wonder if there's such a thing as a to the 0, and what would that be? We use 3's again like we did before. 3 on its own equals 3 to the 1. What would 3 divided by 3 be? Well, we can see a number over itself is always 1. And using our rules of indices, that's going to be 3, 1, minus 1. Because that's 3 to the 1, and that's 3 to the 1. That's 3 to the 0. Which equals number over itself, 1. And that's something they often ask. It doesn't just apply to 3's, of course, it's 4's, 5's, any number you can think of. So in general, a to the 0 equals 1. It seems to be a favourite question in the exam. Okay, let's move that up. We now go a bit further. Let's look at 3 times 3, which is 3 squared of course, divided by 3 cubed. And using our rules of indices, 2 minus 3, 2 minus 3 is minus 1. And what happens here? 3, 3, 3. It's a 1 then, isn't it? 1/3 equals 3 to the minus 1. Whenever you see this, if you see a negative, it means we've got a reciprocal there. I'm going to put a general rule down. Right, now I want to look at fractional powers. So what I'm going to do is put down 25. And that is 25 to the 1. Well, that equals 5 times 5. But using our rules of indices, I could actually split that 25 up into 25 to the half times 25 to the half. Because these add together to make 1, 25 to the 1. So 25 to the half is the same as 5. So the half power is the same as writing the square root of 25. And now we'll look at 3's and do the cube and see what happens there. 3 times 3 times 3. 3 3's are 9 times 3, 27. But I could just as easily write this as, well, not just as easily, but I could write it like this. Because that's to the 1. 1/3 plus 1/3 plus 1/3 will make 1. 27 to 1/3 is the same as a 3. 3 times 3 times 3 makes 27, and this lot times itself makes 27. We can say that 3 equals 27 to 1/3, which is the cube root, and normally we show it like this. Okay, so we have another rule then, so let's put that down. Okay, a little bit more and then we'll do some examples. 3 squared, and we'll cube that. Well, that's the same as doing 3 squared times 3 squared times 3 squared. And using our rules of indices, this one up here, where we add them, that'd be 3, 2 plus 2 plus 2, or 2 times 3. So our rule is, well, in this example, it's 2 times 3, so it becomes a multiple. Instead of adding, when we put it in a bracket like that and we cube the whole lot, we multiply it. Okay. We'll put that down. I'm not going to show this as a rule, but consider this anyway. If we had 3a squared and we cubed that, what would we get? We would end up with, using our rules of indices, we would end up with 3a squared times 3a squared times 3a squared, 3 times 3 times 3, 27, and 2 times 2 times 2, a to the 6. And that's using this rule here. 2 times 3, 6. And this one here, this was 3 to the 1. And it's 3 to the 1 times 3, which is 27. Or you could write it as 3 cubed, a to the 6. So when these are like this, we multiply 3 times whatever the indice there is and 3 times whatever the indice there is. Okay, I'm not going to put that as a rule, I'm just going to leave it. And we'll do some examples, and where that comes up, we'll address it then. Okay. Okay, start off with a straightforward one. Evaluate this. 3 times 3 is 9, times 3 again is 27, and 3 27s, well, 3 7s are 21, and 3 20s are 60, 81. Okay. Next one. So we'll simplify this. Well, that's a to the 1 and a cubed, and using our rule here, we add them. So that's going to be a, and we'll actually show it this time, 1 plus 3, and it's going to be x to the 2 plus 3 x to the 5. Done. Try this one, and we'll raise that to the power of 4. And now we use this rule here where we multiply them. So it's 2 times 4, a to the, I'll write it in like this again, 2 times 4, and b, 3 times 4 gives us a to the 8 and b to the 12. Okay, a few more examples. Okay, 36 to raise to the power of a half. We know from this rule here, it's the same as rooting it, and it's the square root. Square root of 36, 6. Well, it's plus and minus 6, isn't it, really? And another one. Well, that's the same as writing 72 over 1 divided by 72 over 1. And we know that anything raised to the power of 0 is 1. Easy one. 9 to the minus 0.5. Well, 0.5 is the same as a half. But my way of doing it is always get rid of this negative first. We know that that makes it a reciprocal, this one here. So the first thing we can write is this. 1 over 9, and the 0.5 stays there. We know that that is like rooting it here. So that is going to be 1 over the square root of 9, which equals plus or minus 1 over a third. And we'll do another one, a bit more complicated. Okay, let's look at this. (16) over 81 to the minus 3/4. The negative tells us it's a reciprocal. So we can just invert this. So we can write this now as to the 3/4. Always do this root first, so get rid of this. Okay, which number times itself 4 times makes 16? Well, it's 2 times 2, which is 4, times 2, 8, times 2 again, 16. So that number on the bottom there is a 2. And on the top it's a 3, because 3 times 3 is 9, times 3 again is 27, times 3 again is 81. And that leaves it, and then we've just got to cube it. So we've got rid of this 4th root, now we've got to cube it. The cube of 3 is 27. The cube of 2 is 8. And we can leave it that. We could make it a mixed number. 8's into 27, 3, and 3/8 left over. Okay, let's stop there. If you found this useful, then please click the like button. And if you'd like to see a few more examples, then please leave a comment. And if you wish to, and you've not done already, then please subscribe. Thank you for watching.